always opposite the longest angle. The smallest angle is always opposite the smallest side. So here with the triangle longer side theorem, in this triangle right here, which angle is the longer angle?
B.
Do not know anything about B. Well, I guess, you know what, if we're just looking at the picture itself, it does kind of look like the side opposite of B is the longest side.
Did you mean the one that actually had an measurement?
Yeah, I meant one that we can actually determine. So C would be longer than what, or longer, greater than which angle? So measurement of angle C would be greater than measurement of angle A because the sides opposite are longer. And then same kind of question in this one. Let's say which angle is small, which side is smaller. You can tell which angle is smaller, but which side is smaller of the two sides that we can actually determine? Ooh, actually we could do all three. Let's put them all in order. Which is the smallest side? Maggie? Side, do you care if I call it AB? Is that okay? Okay, so side AB is the smallest side. What is the medium length side? BC. And then which is the longest side? How do you know though? Because there's no angle here.
Because the triangle, the angles add up to 180.
Mm-hmm.
Yeah, you have 50 and 30, and 110 is bigger. And 100 is bigger.
100 degrees would be the third angle by the triangle sum theorem. Perfect. That's exactly what he said. All right, here you go. List the sides and the angles of the triangle from shortest to largest. The sides and the angles from shortest to largest. I'll do one, and then you could do. You can work ahead of me too, because you're probably way faster than me. So the sides from shortest to longest. Oops. Okay, so I put JK, JL, LJ from shortest to longest sides, and then that makes the angles measure of angle L, measure of angle J, measure of angle K. Notice I'm writing measurements for all of these because we're talking about the length of them. Question B, how to find that missing angle. So the angles would be measure of angle E, measure of angle D, measure of angle F, and then side DF, side EF, side DE. And one thing you should notice when we're writing these in order from shortest to largest, if I look at measure of angle E right here, and then I look at the side that is opposite it, it does not have an E in it. Or if I look in the middle here at side EF, the angle does not have an E or an F. When they're opposite, they won't have the same letter in them. Okay, you try them. You didn't try A and B yet. You try. grade people would do that. Well, David, you're already on paper. You might as well finish that. You're over here trying to type it. You have questions. So you put your segments in the and then put a little M in front of the measurement. You guys see in my angles? I'm looking at answers now. See in my angles, I have a little M in front of the angle. That means the measurement. So it's not just the angle itself, it's the measurement of that angle. So Alex, while he's typing, he's using this for angle that helps you a little faster. Okay. Have you had a chance to look at my answers?
Oh crap. I didn't get one wrong. I just rewind.
So when we end up taking a test on this stuff, this would definitely be a nice little grade booster. It'll be on the test. Don't want to make silly mistakes because we rush through it because it's so easy, right? Who's got questions? Rakai, what's your question? For number B. I know, I say it too. What did you start with, the sides or the angles? Okay, did you get 60 for this one? Right, so did you get your angles wrong? Oh, geez. Did I get my angles wrong? Did I get my angles wrong? Yes. Then why is nobody else saying anything besides Rakaya? Did I do it on purpose to see who's paying attention? You'll never know. Okay.
Maybe it was an accident and you're just trying to cover up.
You'll never know. So I will tell you when I did it. I just wrote these, and then I didn't even look at this picture. I just looked above it and was like, this is A, so I'll write BC. This is C, so I'll write AB. Oops. And then the third one's B, so I'll write AC. That's how I did the second part. I was just looking at this. Yeah, I don't know why I put this in the wrong order. I have no idea what happened there. You mean for question B? Because the smallest angle is across from the smallest side. So when I know the smallest angle, I know that's got to be the smallest side. Yes?
So like angle B, angle CA would be the longest angle, right? Because it's across from it. Is that how it works? So like the biggest angle equals the biggest side that's across from it?
Yes.
Okay, and it just goes from the
Yep. Because I showed you when we have an angle, you know, the side lengths, these two side lengths aren't moving, but like this will determine how big the other side is. So because of that, that's why we're able to have this theorem that allows us to put the sides in order, even if we don't know the side measurements themselves, if we know the angles. All right. The triangle inequality theorem. The triangle inequality theorem. All right, so I'm going to pause the video because I have to show you something and I can't really do it under here. So here is the triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the third side. The sum of lengths of any two sides of a triangle is always greater than the length of the third side. So a triangle has one side of length 14 and another side of length 9. Describe the possible lengths of the third side. So we've got one side is 14. We've got one side is 9. And we need to figure out what are those possible lengths of the third side. What's something that we know for sure about that third side using the triangle inequality theorem? It can't be what? It can't be 23.
So is it
Can it be more than 23? No. So the sum actually has to be less than equal to 23.
wait, equal to?
Not equal to. I don't know why I said. You know, one of those days. Okay. The sum has to be less than 23.
And then does it have to be more than 14?
Good question. Is there a limit on when we start going down below 23? Is there some place where you're like, oh, nope, it's got to be more than a certain number? Like, can it be 14, 9, and 1? Because what you got to do is you have to remember that, like, if I add these two sides together, they have to be bigger than the third side. But, like, the triangle turns, and now 14 plus this has to be bigger than this side, which I think everything would be at that point. But also here, 9 plus this has got to be bigger than 14. So 9 plus what? 9 plus 5. If I take 9 plus 5, that equals 14. So this side here has to be greater than 9. So my sum is going to be in between 9 and 23. Is there a way that I can, just kidding, 5 and 23? Because that's 5, yeah. Is there a way that I could get the number 23 and the number 5 from these two numbers? You got those numbers from these two numbers. How could I get, if I add the two numbers together, I get the biggest number. And then what, Avni? If I subtract the two numbers, I get the smallest number. Guess what? This is going to work every time. So a triangle has one side of length 6 and the other side length 15. Describe the possible lengths of the third side. So what could that third side be in between? So 6 plus 15 is 21. And 15 take away 6 is 9. So that would be it. In between 9 and 21. Is it possible to construct a triangle with sides 8, 9, and 18? The sum of two sides has to be greater than the third side. So if I add 8 and 9, it has to be greater than 18. If I add 8 and 18, it has to be greater than 9. And if I add 9 plus 18, it has to be greater than 8. So is 8 plus 9 greater than 18? No, it's 17. 8 plus 18 is greater than 9. 9 plus 18 is greater than 8, but all three have to occur for this to be able to be a triangle. So can this be a triangle? No. Because the sum of 8 and 9 are not greater than third side, 18. All right, and then the last one, you try. Is it possible to construct a triangle with sides 5, 7, and 12? yeah, triangle, or no, not a triangle? Why not? Because 5 plus 7 equals 12. It is not. Did I just do all of these the wrong way? What is wrong with me today? I like have them every other day though. Okay, so this one does not work. I know what I meant. All right, last thing of the hinge theorem. I actually showed you guys the hinge theorem, kind of. If two sides of a triangle are congruent to two sides of another triangle, so I've got two sides of a triangle. They're not, I've got to zoom out though. They're not the same length as each other to two sides of another triangle. Maybe I should actually use two that are congruent. I've got a blue pen with a cap and a purple pen with no cap. That's part of a triangle. And then same thing again. No cap, cap, cap. And I can't read my words. And the included angle of the first is larger than the included angle of the second. So the angle between these is bigger than the angle between my red and blue ones. Here, I'll make it really bigger. Is this zoomed out enough? Probably not. Okay, is that good? All right, tell me about the side. So the sides are totally congruent. The one on the left has a way bigger angle than the one on the right. Tell me about that third side. Oh, come on, guys. We were just doing this. I'm just standing up doing this with rulers. If I have two sides, and these two sides are not going to change in length. If I've got an angle like this, here's my third side. If I have an angle like this, what happens to my third side? It gets bigger. So if I've got two triangles, they have the same, they're congruent sides, their corresponding sides are congruent. See, I chose like things that are the same length. I've got one triangle that's got really skinny angle here. The other triangle looks like this, really big angle. Tell me about that third side. Compare them to each other.
One longer than shorter.
Yeah, which one's longer?
The wider angle.
The one with the bigger angle is longer. Exactly. It's called hinge theorem because where do you see? Where do you see hinges? Yeah, on doors. So it's like we're using a door, which is affecting. That's another thing. If you think about the angle that the door's open, you know, like it's all the way open. It says you have to crack the door. There you go. Right. And then the hinge converse, two sides are congruent to two sides of a side. The first is longer than the third side than the first. In this picture, we've got two congruent sides. This side is longer than that one. Tell me about angle E or C compared to angle F. If this side is longer than 9, then C is what to F? Bigger. That's the converse to the hinge theorem. So here, example 4, given that segment ST is congruent to segment PR, how does angle PST compared to angle, or the measurement of angle SPR? Okay, so we have given that ST and PR congruent, this is already marked for you. We also know that these two sides are the same. So I'm looking at angle PST, which is this one here. And I'm looking at angle SPR, which is this one up here. how do they compare? What inequality sign should I put in here to make it true? Well, look across from this angle, the PST. Look across from PST. I have 24. Look across from angle SPR. I have 23. So what goes here? Greater than. Why does it go greater than? Right. Logic. You try. Given AB congruent to DE, BC congruent to EF, how does angle B compare to angle E? Measurements. Compare their sizes. Maggie, what do you think it is? The angles are equal? No. B is bigger, greater than. Because the side opposite B is greater than the side opposite E. Right. Given that JK is congruent to LK, JK is congruent to LK, how does JM compare to LM? JM compared to LM. So we've got two sides congruent, and we know the angles that are included between those sides, so we're just going to determine about JM and LM. Matthew, what do you think? Why? Because the opposite angle is larger. Yep, 64 is bigger than 61. All right, and then AB congruent to DE, BC congruent to EC. We know measure of angle B, we know measure of angle E. We need to know how AC compares to DC. Jesse, I'm going to call on you. Need to know how side AC compares to side DC.
AC is greater than DC.
Okay, and why?
Because angle measurement of B is 48.
Uh-huh.
Greater than what is shown on the angle E, which is 47.
Right. So they're opposite angles. AC has a bigger opposite angle, so it's going to be the bigger side. That's it for the new stuff. What'd you think? No. So we're going to take a quick brain break, and then I have a worksheet for you to work on. Yeah.